Hi everyone. Today we are seeing the topic is paging in computer architecture. So paging is a fixed size partitioning scheme. It is used to separate the content and it will be stored in the memory. So basically the memory will be classified into two types. One is main memory, another one is secondary memory. Main memory is a temporary memory and secondary memory is a permanent memory. So both the memory can be divided for storing the data inside it. So that division is fixed size representation by using your paging. So partitioning of secondary memory called page frame. So if you are storing the data with the help of partitioning, so each and every data will be stored in the form of page frame. So in this, we are having each and every data will be stored in memory with the help of address representation. So we are having majorly two types of address representation. One is virtual address, another one is physical address. If you are representing in the secondary memory with the help of virtual address and by main memory in the help of physical address. So once the data will be executed, at that time the data will be taken from secondary memory to main memory, because all the type of execution can be done with the help of main memory. So if once that execution will be completed, you have to write the result in the secondary memory. Then only we can verify the data after complete our process again. So, visual memory to conversion of physical memory translation is very important while we are using the paging concept. So, in this paging representation, we have to convert the virtual address to physical address, because that secondary memory data will be taken from the secondary memory and it will be located to the main memory for the execution. So, in this representation, we are having a two phases. One is segment translation, another one page translation. So segment translation, we have to represent, it is also called as segmentation. So because it will be identifying the data where it is located in the secondary memory, and also it will be identifying the virtual address for the actual data. The next one, page translation, it will be transforming the sequence, or it will be transforming the segment which we are taking from the which we are taking from the virtual address, it will be converted to the physical address. So that segment will be converted to the physical address with the help of page translation. So in this representation, we are having one buffer name, that is translation look ahead buffer. So it support the paging concept, and in the it is used for virtual memory. That process has to execute the page table which is held by the main memory. So it is a small portion kept in the main primary, it will be maintaining the memory management unit is called TLB. So what is this thing is, so each and every time if you are having a book, at that time book having an index page, so from this index page we can identify the location of your content in the book. The same thing, if you are representing the paging, so in this virtual memory, we have to execute the content with the help of your processor in the form of your main memory. So the small portion will be kept in the main memory, and also the management will be represented for the paging segment with the help of your TLP. So next one, page fault and demand paging. So in this representation, so page fault and demand paging. So what is the meaning of page fault? If I'm recording one page or a recording one instruction, it is not found in the memory unit. So automatically we can identify it occurs, it is a page fault. And we have to use some other routine to load the data in the uh, to load the data for your page fault representation. It is called a page fault routine. So if you are having a getting a desired page to load in the main memory is called demand paging. So what is the thing is, if you are searching on page, it will not found by the memory unit. So automatically it will be representing a page fault. So again, we can upload the data from secondary memory to again main memory. At the time, it will be representing as a page fault routine. So after loading the content in the main memory, that unit will be representing as a demand paging. So page fault routine is used to identify, or it is used to retrieve the data from the secondary memory to main memory. And also the main memory data, the data will be loaded in the main memory with the help of your demand paging. So we are having this representation, we are having a page replacement algorithm. So the page replacement algorithm is used for supporting your demand paging concept or demand paging technique. So various types of algorithm used for your page replacement. So in this mainly we are using FIFO, that is first in first out algorithm, optimal algorithm, least recently used algorithm, that is LRU algorithm, and counting algorithm. So in this first in first out algorithm replaces the new pages with the old page. Suppose if you are having a 601230, likewise we can load the data. Once the new page will be loaded, now automatically the old page will be replaced with the new page, because the page size will be a fixed one. So if you're having a 4 data will be stored in the page table, so I can add the fifth data automatically in this, the page replacement, which one can be replaced, the older data will be replaced with for the new one, that is first in first out service. So next one, optimal. So optimal algorithm. So the optimal replacement has the lowest page fault rate of all. We can identify that the page replacement can be used. So what is the meaning of replace the page that will not be used for the longest period of time? So which page will not used by the processor in the longest period of time, that page will be replaced for the new one. So next one, least recently used. So the same, which one will not use to the longest period of time in the processor, that page can be replaced for the new one. So that optimal algorithm is the same as LRU algorithm, that is least recently used algorithm. So the next one, counting algorithm. So the counter is used or it is maintained to check the number of references that have been made to each pages based on the current count replacement occurs. So thus LRU algorithm, smallest count replaced. So that means which page will not use to the longest period of time means the count of the particular page will reduce, that is having a small count. Which page is mostly used, that page count will be high. So based upon this count, we can replace the page. For example, I can use a 1 to 5 pages. In this third page, I will not use longest period of time. So that count will be 2. So other remaining pages count will be 4. So in this, which one is the least frequent, that is least frequently used? The third one is least frequently used because that counter is 2. Most frequent use, remaining all fours are most frequently used. That time the page can be replaced with the least frequently used, means the third page will be replaced with the new one. So these are the representation while using your paging concept. So paging is used for allocating the data or allocating the instruction to the memory, and also page replacement. So that is a fixed data. We can't extend the memory bytes for the new data when once arrived. So at that time we can use a replacement algorithm to utilize the page for. Thank you.